Good morning everyone, myself Dr. Inderjit Kaur, Associate Professor in the Department of Computer Science and Engineering at Ajay Kumar Garg Engineering College, Ghaziabad. After covering the different types of cache memory mappings, in this lecture we will be discussing about the auxiliary memories. They are also called as secondary memory to store the large amount of data, and in this we will be covering magnetic disk, magnetic tape, optical discs, etc. So, starting from the term what we mean by the auxiliary memory. Auxiliary memory, that is also known as secondary storage, or we can say it a secondary memory, or that is externally connected to the CPU, that is external memory, or we can say that is used for taking the backup, storing the backup. So, it is defined as backup storage memory or also called as mass storage media. So, what it is used for? The usefulness for this auxiliary memory is it holds that is not currently being processed by the CPU, but it is ready when it is required by the CPU. As we know, we require CPU when we want to execute any instruction. So, whenever any instruction that wants to get executed, it should reside in main memory, and because of the size limitation, everything cannot be accommodated inside the main memory. So, whatever has to get executed, whatever instruction or whatever program has to get executed, so they will be residing in the CPU. So, rest all, because of the storage limitations, they will be stored somewhere, either in our pen drive, either in our magnetic disk or CD, ROM or hard disk, etc. So, when I am saying that they are being saved into the secondary storage, so they should be residing permanently. That means, this memory, it is non-volatile, the contents remain when we even switch off the power. So, then it has very large storage capacity. The data, large amount of data can be stored inside this, and they are useful for transferring the data or programs in the form of input. We can store different type of data and programs in our auxiliary memory, and they are being used for transferring from one computer to another, and we can also use them second for storing any amount of our results that are obtained after processing, that is the output. So, input and output we can store both things in our auxiliary memory. The examples for this auxiliary memory, they are floppy disk, hard disk, CD-ROM, DVD, zip disk, pen drive, etc. We will be covering them in detail. Based on their types, we can divide all type of these auxiliary memories into two categories. One is known as magnetic storage. We can see they all come under magnetic storage, and this is our optical storage. The example is CD or DVD drive. So, if we categorize them, one comes our magnetic and another comes our optical. Magnetic means the devices they are using disk or tapes, they are coated with magnetic sensitive material, and this magnetic sensitive material coating it allows them to store the data in the form of zeros and ones, and they sense it, means we can read and write, we can perform both operations, read and write the data or programs in from our magnetic storage technologies. Then the second category is our optical. The devices they use the laser beams to perform the read operation, means to read the different patterns that are etched into the plastic disc, and they also perform the write operations whenever laser beam is coming to them at their specific points. So, how can we categorize the types of different auxiliary memory? They are being categorized basically the two types based on their data type. First is the sequential access media, and the second is random or the direct access media. First, that is the secondary access media. As the name is suggesting, we will be reading the data or the programs in a sequential manner. We cannot go directly to any point, that is the data can be read in the sequence, or suppose we want to go to a particular point on the media, then we need to go from the starting, then we will be moving on to the proceeding points. Then in the second case, suppose I am talking about the random or the direct access media, as the name suggests. So, the data, it can be accessed at any point randomly without passing through the preceding point. So, that is the reason it is being called as direct access media or the random access media. So, we are going to start with the first magnetic tape, that is a kind of auxiliary device. This magnetic tape, it is magnetically coated strip of plastic on which the data can be encoded, means data can be stored. We will say that this magnetic tape, it is a kind of secondary storage device, and it is primarily used for taking the backups for large amount of data, and this data, the data or programs that is being stored, that is in a non-volatile manner. It is it does not mean that once the data is being stored and when I switched on or connect this device with onto the CPU, after that the data will be deleted after some time. This is not the case. So, that means the data is stored permanently and it is not volatile by the nature. These all devices, they are connected with the CPU, they are connected with our main memory. The CPU is communicating to the main memory. CPU is first searching the data or the program. Once the address has been generated by the program counter, it first looks into the cache memory. If the data is found, then it is known as hit. If the data is not found, then it is known as miss. So, if in case of miss, then it searched into the main memory. Again, the data will be searched into the main memory and we will be calculating the access time accordingly. So, again if the data is not found into our main memory, then it has to brought into the main memory from where it is residing. For the user, it seems, for the programs, it seems that there is a large amount of main memory in the form of virtual memory, but actually the data is being stored in somewhere secondary memory, either of tape or disk or CD drive or pen drive or hard disk. So, from that secondary device, the data will be actually brought into the main memory. It will occupy some address locations into the main memory, whichever they are free, and if the some address locations they are not free, then they will be freed according to the block replacement algorithms that we have discussed in the previous lecture, like LRU or FIFO or any random, and then the instructions means the set of instructions for a program, they will be executed. So, in this manner, for the programmer it seems that all the instructions they are being residing into the main memory, but actually the data has to be brought from the secondary memory to the main memory. Again, second thing, when the data is being brought from the secondary memory to the main memory, there can be size mismatch also, fine. So, in that case again we require mapping from the secondary memory to the main memory, and if the data is accessed repeatedly, the same data has been demanded by the CPU. So, that data will be stored into the cache memory. So, we can see these two things, from cache memory we are moving to main memory and then we are accessing the secondary memory. So, when the address is being generated by the CPU, it is firstly searched into the cache. If it is not found, it is being searched into the main memory, and again if it is not found, it is being searched into the secondary memory, and repeatedly use of the data has been copied into the main memory, and again if it is required, then this data has to be copied into the cache memory. The procedures of writing into the main memory and the procedures for writing into the cache memory, they have been already discussed. This write through and write back were the procedures that we have discussed earlier into the cache memory, and writing into the main memory is directly writing once it should be mapped from the secondary memory to main memory. That means, how we are moving from virtual memory to main memory. Then this magnetic tape, it is made up of mylar. This mylar is a plastic material that is coated on one side of the tape with magnetic material, that is the iron oxide. So, wherever is the coating of iron oxide, it will get oxidized and the data will be read or written in the form of zeros and ones. So, the devices that record and play back the audio and video using magnetic tape, they are the tape recorders or the video tape recorders. They are the examples when we are storing the data into our magnetic tape. So, next is the characteristics of magnetic tape. If I say the magnetic tape unit, it has a read write head. It is in the form of the data is stored in the form of tracks. These tracks, they are further divided into the sectors, and where the data is being stored in the form of sectors. There is one common read and write head that tells us the which kind of operation is being performed. Then there are erase head, then there is a erase head that erases the previously recorded data if it is not required. Then this magnetic tape, it is inferior to disk because it is not as much reliable, and secondly it gives us the sequential access to data. We cannot move on directly to any kind of data, we have to move into a sequential manner. Then the most commonly advantage is it is inexpensive form for storage the data or programs, and it stores megabyte of storage, that is very much a large amount of data can be stored, and primarily it is used for storing the backup, and it can store large amount of data, as we have said maximum up to 1 terabyte per tape. The examples are floppy disks, or we can say audio cassettes that we have seen in our childhood. These here we can see this is the kind of magnetic recording. Suppose this is our tape motion going on, this is the magnetic field, and this is our plastic tape, upper end has plastic tape. So, in this manner the tape will move on, and this is the plastic coating in like concentric circles, and here we have the read write head. The position of read write head tells us in which direction we are moving on. This is the magnetic recording tape. This is how it is being divided into different tracks. The data is stored in the form of zeros or ones. These are the different tracks, and here we are storing the parity bit that is used for error correction and detection. Then this is the organization of data on the magnetic tape. See, this is some gap, then we are storing some kind of data in the form of zeros and ones, then again there is a record gap being given for error correction, then again we are storing some data in the form of zeros and ones, and this is the again some kind of record gap, this is the end of file. So, in this manner the data is being stored. Then suppose we give a problem, what is the transfer rate of 8 track magnetic tape, tracks are given as 8, whose speed is 120 inches per second, and the density it is given to us is 1600 bits per inch. So, we have to calculate the transfer rate. So, as we know the data is being stored like this. these are our different sectors that are being divided into different tracks, and in one track we have shown ki this kind of data. It seems that in this linear kind of data is being stored. This is our one location, this is our second, third, fourth and so on. Actually the data is like this and it seems like this. So, transfer rate, it is 120 inches per second into 1600 bits per second per inch, sorry, will come. So, it comes out to be 192,000 bits per second. So, if I divide into bytes, so I will be dividing it by 8. So, it comes out to be this will be the transfer rate of this magnetic tape that has the speed of 120 inches per second, and it can store the data of 1600 bits per inch. Then the second device, it is the magnetic disc. So, this disc, it is a formatted, it is divided into tracks and sectors and a file allocation table, that is FAT, it is created for every disc. So, here we can see from the diagram, this is our magnetic disc that is divided into different sectors. These whole are the circles, they denote the sectors, and they are further this yellow, it denotes a particular track, a particular memory location that shows the particular address location where we are storing data or program data or instruction actually, and this is our cluster. So, track, it is a circular band as we can see, and sector, we can say this pie shape section, it shows us the sector. This is one sector we can say, and cluster we can define it, two or more adjacent sectors, they are known as one cluster, and we create a file allocation table for every magnetic disc, that keeps track of the specific locations of the particular files that are being required. In a magnetic disc, every track and every sector, it has a number, and in general the commonly used magnetic disc, they have the size either 1/4 inches disc, and in this size we have the 40 tracks with 9 sectors each, and if we take this 3.5 inches disc, then there will be 80 tracks with 9 sectors each, and then in this case we define a cluster, that is a set of track sectors, or that in this the cluster will range from 2 to 32. So, this diagram, it shows us the rotating structure of a magnetic disc. So, it rotates on a rotating shaft, it has a spindle, and this spindle, it is divided into a moving arm like this. So, this arm, it is divided further into the different sectors that we have discussed, and on these sectors we are storing actually the information. We have a one read and write head that is telling us which operation on which sector has to be performed. So, this is the bit representation of magnetic disc, in which we can store the data in the form of zeros or ones. So, like this it denotes 0 and this denotes a 1. So, like this magnetic coating is there of magnetic material, and this is the direction of magnetization in which we can store one bit, that either it will store 1 or it will store 0. They will be the actually their ASCII code, it will be converted into one alphabet, and we will be actually processing that data into our ALU. So, this shows the mechanical structure of a magnetic disc. So, this is our spindle, as I have said earlier, the below one and the upper one, it has a single side coating. That means, in this diagram, this is divided into different surfaces, the surface 0 and the last surface n, in this case the 7th, the data can be stored on one side. Otherwise, in the inner surfaces we can store by data on both sides, because it has coating on both sides. So, on every surface we have read and write head that clearly tells us on which surface, that is again divided into different tracks, we are actually storing the data. So, like this we can see the disk data layout here. It shows the different tracks. These are the inner track, that shows the innermost, then like this and in this manner it will go. So, these are the different sectors that are being further divided into different tracks, on which data in the form of zeros and ones they are being stored. There is one there are different inner track gaps also, that tells you the difference between two adjacent tracks, and this shows the gap between intersector, means there is a gap between two corresponding sectors, so that different padding is being done to handle the error correction and error detection. This is the read write head that shows, this is our magnetizing current being flowing on the magnetic yoke, and this is our magnetic thin film, and it is the air gap. So, the direction of this, it will tell us which operation on which track has to get performed for a particular sector. So, this disc, it is divided into different sectors, then the different sectors like S1, S2, S3, S4, S5, S6 and so on, and for a particular sector, that is again we are divided into different tracks. Two corresponding tracks, they have a gap also, two corresponding sectors, they also have the gap. Then it is a we can say it is a rigid disc that is coated with a magnetic material that we have seen, on which the data and programs can be stored, and we can say that it uses the magnetism to store the data on a magnetic surface. The main advantages for using the magnetic disc is, it has a high storage capacity, it is very much reliable, and it provides us the direct access to the data. This direct access is very much important. We can go to any address location directly rather than moving from the start. Then the second advantage, we can perform read and write operation both by using the read and write head. Then the third device, that is our optical disc. Optical disc, that is an electronic data storage medium that is supporting us to perform the write and read both operations using a low powered laser beam. So, where that laser beam will pinpoint, accordingly the operation will start from that location only. It can store up to 6 gigabytes, that is 6 billion bytes can be stored on a optical disc. Then it is made up of a material resin, that is such as the example for resin is polycarbonate, that is coated with highly reflective material, that is aluminum, or also we can use the silicon, silver or gold, whatever, and suppose we are using the 5 doubled DVDs, then we can use the silver and gold. Then we can store the software, we can store the data, digital photos, movies and music in case of optical disc. Then there are 4 kind of basically optical disc type. One is our CD-ROM, that is known as compact disk read only memory. We already using this. So, this CD-ROM it is used for storing the operating system, large applications or multimedia programs, and on a single CD we can store 650 MB of data. Then the second type of optical disk type, it is WOM. This WOM stands for write once and read many. That means while using WOM we can write data only once. The advantages, most commonly advantages for using this WOM, they are high capacity, they have longer life and they give us the better reliability. Then the third kind of optical disk type, it is the EOD. This EOD stands for erasable optical disk. This erasable optical disk, the contents they can be erased and the new data can be rewritten to it by erasing the already existing contents. Then this EOD, it is used as the secondary memory of the computer also. Then the fourth kind of optical disk drive, it is DVD. That DVD means a DVD, it is data is divided into two layers basically, and the data can be accessed from one or both side when we are accessing it, and the data it cannot be changed when it is being stored or created on DVDs. Then basically we have categorized our memory into two parts. One is primary memory and second is our secondary memory. So, primary memory we have covered it into the earlier lectures, that was our RAM and ROM, the main that is main memory. The CPU is directly connected to the primary memory and it is accessing to that. And the second type, it is the secondary memory that we have discussed in this lecture now, that is also known as auxiliary memory. So, we will firstly differentiate them, कि what is primary memory and what is secondary memory. So, let us have a recap. So, the memory devices that are used primarily, they are semiconductor memories, and in case of secondary memory, the devices either they are magnetic or they are optical memories, as we have said that. So, the primary memory, it is being categorized as volatile or non-volatile. In that, RAM will be our volatile and the ROM will be non-volatile, whereas secondary memory, it is always non-volatile. Primary memory, we will say it as a main memory, and the secondary memory, it is known as additional memory connected to the CPU, or we can say the backup memory. Then primary memory, it is called as the internal memory of the system, and it is known as the external memory of the system. So, this was all about the auxiliary memory, the different types of auxiliary memory, magnetic disk, magnetic tape, optical disk, and the type of optical disks. Thank you.